Welcome back. We are still on the features of periodic table. So a gathered change in a certain property within a group, or known as a group trend, is due to their increase in what? In atomic what? Numbers. So the higher the atomic number, the more the changes. That's why sometimes you have a group of for example, the halogens. The first two elements there are what? Are gaseous, which is fluorine and what? And chlorine. The next one is bromine, which is liquid. Why? Because of the increments in what? In the atomic number of bromine down the group. Then the next one is what? Is solid, which is astatine. Is that okay? So the gradual change is due to what? Due to their increase in their atomic numbers as they are going down the group. Okay, the electropositive character increases, okay, across down the group. Then their reactivity also what? Increases down the group, and also what? Their reactivity element of non-metals also what? Decreases. That means that in the case of the group 7 elements, this is group 7 element, for example. Now, the reactivity of group 7 elements decreases. That means that fluorine here is the most reactive. So the trend comes down from fluorine down to astatine. All right? Fluorine is more reactive, followed by fluorine is more reactive. Okay? Chlorine is less reactive. Bromine is less reactive. Iodine is less reactive. So fluorine here is what? The reactivity what? Decreases down the group, but increases up the what? The group. Don't forget that. Most reactive, less reactive. When it comes to metallic character, the same thing. This is a reactivity. All right. Francium is the most reactive metal. Okay. It's reactive, but sodium is more reactive than this. Potassium more reactive than this. Until you get to francium. All right. So it's the opposite of reactivity of non-metals and that of what? And that of metal. Okay, that takes us to the next thing, which is called the properties of the periodic table, the last segment of this video. All right, and that is called what? Periodicity. The variation, the movements, the terrain of the trends in the periodic table, are they increasing across the period, decrease down the group, and so on and so forth. So when that thing is happening, okay, all sum up is known as what? Periodicity. This is the variation of properties of elements in a regular pattern, both down the group and across the period. So I'm going to look at 4 basically properties of the periodic table. The first one is called ionization energy. What does that mean? So the energy that is released, okay, when a metal, now listen, because this is where the question comes from most at the time, is a very confusing part of this periodic table. All right. Now this is a normal metal. M stands for metal. It can be lithium, it can be sodium, it can be magnesium, it can be calcium. I'm just using to illustrate other metals. Now this is a normal metal with a neutral charge. All right. What happened here? This metal now loses electron and becomes what? Positively charged. All right. So the energy that takes place when this is happening is called what? Ionization what? Energy. For example, let's take example. Let's say sodium. Sodium here is a neutral element with a what? Atomic number 11. Now when the sodium loses an electron, it becomes what? A positively charged. And here becomes what? 10. It has lost 1 electron and becomes what? 10. And how do you balance it? With 1 E minus. If you look at the elements of maybe the group 2, let's say magnesium for example. Magnesium has atomic number of 12. When you lose electron, it becomes what? Mg2 plus with atomic number 10. And you balance it with what? With 2 electrons. So this process in which what? There is a loss of energy or loss of electron, okay, to form a gaseous atom is called what? Ionization energy. All right, so let's look at the trend. What is a trend like? Now, this process is affected by 3 factors. The first one is the distance of the outermost electron from the nucleus. Okay, don't forget the nucleus. The nucleus contains nucleus of an atom. Let's go back to our elementary chemistry. The nucleus contains proton and neutron, okay, while the electron is found outside the shell. All right, so we talk about the nucleus. Nucleus is basically proton because neutron is chargeless. An electron will revolve around the nucleus of an atom. So this is the first shell, called the K shell, for example, and this is our nucleus, in which proton and neutron is found. So the distance of the outermost electron from the nucleus affects the ionization energy. Then the size of the positive charge, nuclear charge. Nuclear charge also simply means the increase in the number of the decrease in the atomic number of the elements, okay, increasing across the period and down the group. And the screening effect of the inner electrons, the adjustment. Now, what is the trend? Ionization energy increases across a period, but decreases down a group. So it tells me that the tendency to lose an electron across the periods, okay, increases, but it decreases what? Down the group. That means that as you are going down the group, there is a tendency to what? To add electron to each of the shell. And electrons keep on entering the same shell across the period. But it goes down the group, electrons are entering different shell. Okay, I can take you back to the period table. This is my period, all right? Sodium has atomic number of 11, all right? Electrons enter the same shell and give me what? A what? 12. But when it comes to the group, electrons is entering another shell because elements of group 1 has what? Just one shell. Group 2, 2 shells. Group 3, 3 shells. So electrons are entering another shell, making what? The atomic radius to be what? To be larger in size. But across the period, the radius becomes smaller because the more electrons are adding, there is a greater what? Shielding effect that takes place in each of each of the atom. So that is the reason why the increase takes place. Okay, so it increases across the period but decreases down the group. Why? Because of the nuclear charge is increasing, which is what? The atomic number. As you're adding more electron to it, the nucleus becomes what? Decreases in size. All right, because the electrons enter into the same shell, just like adding extra weight to somebody. For example, now you can imagine like 10 men coming close to me, falling on top. If I'm lying down, 10 men are falling on top of me. What will happen to me? I will lose more weight because what? I will lose more because they have more weight than I do. Is that okay? So what is happening to this process here? When electrons are added to the same electron shell, the nucleus becomes what? Smaller, and there is what? Tendency for attraction to take place because nucleus contains proton, while electrons are coming in at the outer shell. Okay, the next process there is what we call electron affinity. Is the opposite of what? Of ionization energy. What does that mean? Now, in the case of electron affinity, there is a gain of electron. For example, E stands for any electron. Let's say chlorine, for example. Chlorine here has atomic number of 11. Now, it will gain electron and becomes what? Minus. Is that okay? And you balance by what? By 1 electron. You can see now, from 17, you have gained electron and becomes what? 18. All right? Now, if it is another element that maybe 2 charge and so on, that is, charge keep on increasing. So, when a negative ion forms readily, a lot of energy is given off. That is, electron affinity has large what? Negative what? Value. What is a trend? It is the same trend with ionization energy. Okay, so it increases with a decrease of atomic radii across the period and decrease with the increased atomic radii down the group. That means as you are entering into the same word period, okay, you are adding extra weight, okay, to the nucleus and cause the attraction to be greater. Because of what? Because of the shielding effect. What am I trying to explain? Now, let's look at this. This is, for example, lithium with 1 atom. Okay? Now, after lithium, maybe I have sodium. Sodium contains 2 shells. All right? The first shell contains 2 electrons. 1, 2, 3, 4, 5, 6, 30 shells. Sorry, lithium. Lithium is 30 shells, rather. 2 shells. Now you can see now, this is lithium. And this is what? Sodium. Both of them are in group 1, but they have different number of shells. But if I go, this is down the group. So you can see what? The size keep on increasing. Electrons are added into another number of shell entirely. That is why this thing is hard like this. Electron affinity increases with a decrease. But if I go across the period, now the next element across period, the next to sodium is what? Is magnesium. Magnesium is the same atomic number, same shell with sodium. Okay? But magnesium contains 2 electrons in the atomos shell. You can see now the weight of the shell has increased, thereby shielding making the distance between the nucleus and the electron to be close by, causing more attraction. Okay? But in this case now, if you go down the group, electrons are added in another different shell, making the atomic size to be increasing. But rather, if it goes across the period, the more electron that comes in, the smaller the nucleus, because of the weight of electron that enters into the nucleus. So the attraction increases. So that is the reason for the trend. Electron affinity increases with a decrease of atomic radii across the period and decreases with the increase of atomic radii down the group. This is because atoms with a smaller atomic radii increase in nuclear charge. That's the reason. Tend to have a stronger attraction for electrons, and so form negative ions more readily. All right, that's the reason for that. All right, so the next one is called electronegativity. This one is simple. What does it mean? The ability for atom to attract electron is called electronegativity. It's the same trend, the same explanation. Okay, the same trend. It increases across the period but decreases down the group. This is because we have been moved from elements to the next across the period. The nuclear charge increases and the atomic radius decreases. The same thing. 2 factors combine to increase electron attraction power of the atom. So as you're moving across the period, what happens? We are increasing the electronegativity. For example, if I look elements of groups, let's say period 3. Yes, you have period 3, for example, the first two groups are metal. So as you move across the period, the electronegativity keep on increasing till you get to to fluorine or to chlorine or to bromine and so on and so forth. All right, atomic radii. This is plural, singular is radius. Is the distance or defined as how the distance between the nuclei when they bond, linking the atoms in a single covalent bond. Or you can say is simply what determines the size of an atom. Okay, so the trend here is the opposite of electron affinity, electronegativity, and ionization energy. So what's the trend? Atomic radii decreases from left to right across the period, but increases down the group. This is because as the nuclear charge increases, the electrons enter the same shell at about the same distance from the nucleus. So you can see now these are 2 bonded atoms. So from this point to this point, this point to this point is called ionic radii, and it determines the size of the atom. So if the electrons are added, into the same electron shell, the nucleus keep reducing. But if the electrons are added to another shell, the nucleus keep on the size of element keep increasing. Okay, and as a result, the atomic radius decreases with an increasing atomic number. Don't forget that atomic radius decrease with with an increasing atomic number. Why? Electrons added to the same shell. Thus, the attraction force exerted by the nucleus on the atomos electrons of the atom increase across the period. In moving down the group, atomic radii increases, although the nuclear charge increases considerably. The extra electrons are entering new shells. I've discussed it before. Electrons are added to new shell down the group, but added to the same shell across the period. That leads to that is, the more the nuclear charge, the smaller what the size of the electron, and the more the attractive force of that particular atom. The last but not the least is the ionic radii. This is the distance between the center of one ion and the center of its nearest neighbor of opposite what charge. Now the difference is that here we have many atoms that surround what that are attracted to each other, unlike atomic radii. Here we involve only two bonded atoms. Okay, now we can see now this is, for example, look at the diagram very well. This is an anion. Anion is a negatively charged ion. All right, cation means what? Positive. So the attraction between this neighboring atom, I think there's a diagram that explains more. Oh, I didn't put the diagram here. All right. So let's see this, for example. We can have more of this, okay, when they combine together. So the attraction between individual atoms, the distance between the neighboring, the attractive forces between the neighboring atom in a bond is called what? Ionic radius. Okay, unlike atomic radii, which involve only two bonded atoms. Okay, so their trend is the same trend with what? With atomic radii. It decreases across the period and what? And decrease down the group. Same reason. Why? Electrons are added in the same shell, okay, but down the group, electrons are added in different shell. So the size keep on what? Increasing. All right, so this is a summary of the periodic table. There are trends. The summary, we can see atomic, this and this are the same. Ionization energy, electron affinity, yes, electronegativity and electronegativity, they have the same trend. Both of them are what? Are increasing across the period. From period 1 to period 2, they are increasing, whereas the rest are the opposite. Okay? They're increasing, and then from bottom to up, they are what? Also increasing. In other words, they increase across the period but decrease down the group. Is that okay? Because they increase across also increase to up, meaning that they are decreasing down the group while they are increasing what? Across the period. Same thing with them. Electron atomic radii, you can see now, atomic radii decrease across the period but decrease what? Down the group. So this picture illustrates all the trends in the periodic table. Okay. Then the last thing is diagonal relationship. Some elements possess the same property, not that they're in the same group, but because they have a diagonal relationship. For example, see lithium. Lithium and magnesium have something in common. We call this what? Diagonal relationship. Beryllium and aluminum have something in common. Silicon and boron have something in common. So this ability in which elements of different groups and different periods having something in common is called what? Diagonal relationship. Okay, some elements show diagonal resemblance because metallic properties gradually decreases across the period but increases down the group. Hence, elements diagonally below one another have similar what? Properties. Now let's look at some of the properties. For example, the ions of lithium and magnesium have something in common. First, they are extensively hydrated due to their small size. 2, they are trioxo carbonate 4 and trioctonitrate 5 undergo ready decomposition on heating. They are tetraoxo phosphate 5 and trioxo carbonate 4 are insoluble in water. Both metals combine with nitrogen at high temperature, and many other similarities. It is for beryllium and what? And aluminum. Just go through the write-up is very self-explanatory and you'll see more. Now let's look at some questions that has to do with periodic table. All right. The first one says, the elements that belong to the third period of the periodic table are, don't forget, third period. Third period. Look at it. Which one do you think belongs to third period? Of course, the answer is D, because this is sodium. So after sodium, we have magnesium, sulfur, and argon. Lithium is period 2. Boron is period 2. So the correct answer there is what? Is D. So element in period 3 have 3 shells. in the atomic structure. These include elements from sodium to argon. All right, question 2. Moving from left to right across the period, general rise in the first ionization energy can be attributed to the, what is the answer there? Increase in what? Nuclear charge. You can say increase in what? In atomic numbers. So as they're moving across the period, there is an increase in what? In their atomic what? Numbers. Okay, look for more explanation on the screen. All right. Next one is the stability of the noble gases is due to the fact that they are, this one is bonus, because they have the complete duplet or octet configuration. They are not collecting electron, they are not giving out, they are stable. So the answer there is what? Is B. Have complete or octet electronic what? Configuration. The next one is elements in the same period in the periodic table have the same bonus. Don't forget, same period, not same group. Same period, they have what? The same number of shells. Period 1, shell 1. Period 2, shell 2. Period 3, 3 shells. Period 4, 4 shells, and so on and so forth till we get to period 7. So as you're moving across the period, they have the same number of shells, okay, but different number of electrons. Don't forget that. Different number of shells, but different number of valence electron. Electron is where it's best explained in terms of their group, because the same number of valence electrons is their group number, but different shells, the same shell belongs to what? The same period, but different what? Atomic numbers. All right. Then which of the following is the correct order of decreasing activity of metals? Which one do you think is the answer here? Don't forget, decreasing. You're going to start from the highest to the least. Don't make a mistake here, because some people will make mistake. When they say increasing means you start from the least to the highest. Decreasing from where? From the highest reactive element to what? To the least. So look at it now. What do you think is the best? Of course, it cannot be A, and it cannot be C. Okay? So your answer is between B and D. So reason, think before I give the answer. All right. So let's move on. Let's see our answer. Answer there is what? Is B. Okay. So this is their correct reactivity. Potassium is more reactive than sodium. Sodium more reactive than lithium. Lithium more reactive than calcium. To get to what? These are transition metals. So they are least reactive elements. All right. Metals of the 1 and 2 are the most reactive elements. All right. But transition metals are the least reactive metals. Okay. Now the last question, I'll be second to the last question here is, beryllium and aluminum have similar properties because the answer is clear. What's the answer? Beryllium, aluminum, they are not in the same group, but they have something in common. Because of what? Because they are positioned diagonally to each other. That is the best answer to the question. So question on periodic table is not very difficult, but sometimes they are very tricky. If you are not careful, you pick the wrong options. All right, the last one, which of the following elements will exhibit the most electronegative character? The most electronegative. Now, you can do your screening from the option. First of all, it can be aluminum because it's a metal. Okay? And it can be phosphorus. It can be what? Silicon. What do you think is the answer? Sulfur. All right? Answer there is D. All right? The elements are all in period 3. As we move from left to right across the period, electronegativity what? Increases. So you can see, so aluminum come followed by sulfur, but the one that is most electronegative is what? Is sulfur. Now, assuming there was chlorine here, sulfur could not be the answer. Assuming there was maybe a one that involved oxygen, sulfur could not be the answer. Because here we have sulfur. Sulfur is what the answer. All right. Which of the following decreases from left to right across the period, but increases down the group in the periodic table? Oh, the answer is there already. It's very obvious. So A, B, C are the same trend, okay? But this is odd among them. So what is the answer there? The answer there is what? Is D. So atomic rate just decrease across the period, but increase down the group. Wow! I wish you the best in this year's JAMB examination. Go and succeed. Till next year. Bye.